Solving linear equations in one variable. We can solve linear equations in one variable using properties of equality. Our goal is to figure out the variable value, what number can be plugged in for the variable to make both left and right hand side equal. Remember, equation is balanced, so whatever we do to one side, we must do it to the other side as well. Algorithm to solve a linear equation in one variable would be step 1 is to eliminate the parentheses using distributive property. Next step would be to simplify the fractions. If there is any fraction involved, go ahead and multiply both sides with the LCD of all the denominators involved in that equation. This will eliminate the fractions. Next would be combining like terms, and then using addition and multiplication property of equality, bring variables on one side. Finally, isolate the variable. Last step would be to check your answer in the original equation by plugging it back in to make sure we haven't made any mistake, left and right hand side are equal to each other. Let's see some examples of solving linear equations in one variable. First example, 15 minus 2x equals negative 4 times x plus 1 plus 9. Step number 1 would be to distribute the left on the right hand side, the negative 4 inside the parentheses. Negative 4x minus 4 plus 9. Next step is to combine the like terms on either side. Looks like on the right hand side we do have like terms, which is negative 4 plus 9 would be plus positive 5. Now my goal is to bring the variables on one side, so we can go ahead and add 2x to both sides. That leaves us with 15 equals negative 2x. It's nice to keep my variable positive, so I'm actually going to add 4x to both sides. That way my variable remains positive. 4x minus 2x is 2x equals, on the other side I'm left with the 5 because negative 4x plus 4x turns out to be a 0. Lastly, I'm going to be isolating the variable by bringing the constant numbers to the other side. Go ahead and divide both sides with negative 2. Negative 10 divided by 2 is negative 5. So x equals negative 5 is a solution. We can check our answer by plugging this negative 5 back into the original equation and making sure the left and right hand side are equal to each other. So let's see, what do we get on the left side? 15 plus 10, 25. Let's check the right hand side as well. Negative 4. So we are plugging negative 5 plus 1 plus 9, which turns out to be 16 plus 9 is 25. So both left and right hand side are equal. That means we did everything correct, and this is the solution to the equation. This number x equals negative 5 is going to make the left and right hand side equal to each other. See another example. This one has fractions involved, so I'm going to figure out the LCD for denominators 6 and 4 and multiply an entire equation on both sides with that LCD. So LCD for 6 and 4 is 12. Now 12 is going to multiply with every single individual term in that equation. 1 6 times 12 will be 2 times n minus 12 on the left hand side. 1 4 times 12 is 3 times n plus 8 minus 2. Let's go ahead and distribute 2n minus 24 equals 3n plus 24 minus 2. Combining like terms on the right hand side, 2n minus 24 equals 3n plus 22. Let's bring the variables to one side. Again, I prefer keeping my variable positive, so I'm going to subtract 2n from both sides. Negative 24 equals n plus 22. Lastly, it's time to isolate the variables, so go ahead and subtract 22 from both sides. Turns out to be n equals negative 46. Again, if you plug n as negative 46 into the original equation, both left and right hand side would be equal, and that's a way to check our solution. Next example, we have q over 6 plus 1 minus 3q equals 2 minus 4q plus q over 8. Again, we can continue working in the fractions if we want. We can continue adding or subtracting in terms of fractions if you want, or we can go ahead and find the LCD for 6 and 8, multiply both sides with the LCD. LCD for 6 and 8 is 24, so every single term on both left and right hand side will multiply with that LCD. So q over 6 times 24, that would be 4q plus 24 minus 72q equals 48 minus 24 times 4 would be 96q plus 3q. Let's combine the like terms on both sides. We do have like terms here. That would be negative 68q plus 24 equals, combining these like terms as well, negative 96 plus 3 would be negative 93q. Let's go ahead and bring the variables to one side. It's better to keep it positive, so I'm going to add 93q to both sides. So plus 93q plus 93q. Now on the right hand side, the variables are gone. Left hand side, 93 minus 68, that would be 25q positive plus 24 equals 48. Time to isolate the variables. So we're going to subtract 24 from both sides. Subtract 24 from both sides. 25q equals 48 minus 24, which is 24. Lastly, divide both sides with 25 to isolate the variable. 24 divided by 25 is the solution here. That's the value for q. That means if we replace q in the original equation, if we replace q by 24 over 25, that would make the left and right hand side equal. Next, we're going to talk about conditionals, identities, and contradictions. Conditional equation is an equation that's only true under a certain condition, like the examples we just saw. When x becomes a particular number, or when the variable takes on a particular number, left and right hand side are equal, and that number is called the solution to the equation. Another example would be identities and contradictions. In a contradiction, we end up with left and right hand side are not equal to each other. Left and right hand side are not equal to each other. In that case, we don't have any solution. We say there's no solution to that problem. There is no value that the variable can take on that will make the left and right hand side equal to each other. We also have identity types of equations. In an identity, we end up with both left and right side equal to each other. The variables cancel at the end, and left and right hand side are always equal to each other. That means there's all real numbers are the solutions. So solution is all real numbers. X can be any real number. We can plug in any value for the variable. Both left and right hand side will be equal to each other. Let's go ahead and check these out. Figure out if this is a contradiction, identity, or a conditional statement. Let's go ahead and try to solve it. First step would be to distribute 4 inside and 3 on the right hand side. 3 times 2 is 6a plus 3. Combine like terms on the left hand side and like terms on the right hand side. It's time to bring variables on one side. When I do that, I'm left with negative 4 equal positive 4, which is not true. So in this case, there is no solution, and this is a contradiction. This is never going to be true. This equation, there's no value that the variable a can take to make the left and right hand side equal. So it's never going to be true. It's a no solution. No, there is no solution to this equation. See another example. Let's go ahead and distribute negative 16x minus 20 equals negative 6 minus 18x. Do not make the mistake of negative 6 and negative 2 making it a negative 8, because negative 2 is multiplied with the parentheses, and we cannot add or subtract until multiplication has been taken care of per PEMDAS order of operations. So right hand side turns out to be negative 6 minus 16x minus 14. Let's go ahead and combine the like terms. Negative 6 and negative 14 is negative 20 minus 16x. If I bring the variables to one side, I would be adding 16x to both sides. You can already see where it's headed. Both negative 20 is equal to positive 20 all the times. So that means this equation is an identity, and the solution here is all real numbers. We can plug in any value for the variable x. The left and right hand side are going to equal each other. See another example. there's a hidden 1 over here. So when we distribute the negative 1 inside, it turns out to be minus 8. So combine the like terms on the left hand side. Negative 5x plus 2x is negative 3x plus 3 equals 11 minus 8 minus 4x. So that would be 3 minus 4x. Now go ahead and bring the variables to one side. It's better to take them to the right hand side. Always keep the x terms lined up under the x terms. 3 minus x. We could bring the variables to the left hand side as well. It does not really matter, but I always try to I prefer to keep the variables positive, which I didn't do in this case. My variable is negative, and that's okay. So this turns out to be 11 minus 8, that is 3. Go ahead and subtract 3 from both sides, and that turns out to be x equals 0, or negative x equals 0, which gives me x equals 0. This would be a conditional statement. That means this equation is only true if left and right hand side are only going to be equal if x takes on the value 0. Let's go ahead and plug it into the original equation to see if it's true or not. And I'm going to plug x as 0 on the left hand side. So that gives me negative 3 plus 0, which is positive 3. Now go ahead and plug x as 0 on the right hand side. 11 minus 4 times 2, 11 minus 8, which is 3 as well. Both left and right hand side are equal to each other, so that means x equals 0 is the solution in this case. And this is a conditional statement, which is only true if x takes on the value 0.